Assalamu alaikum. Chapter Direct and Inverse Proportion. Topics to discuss are concept of inverse proportion, exercise 1c question number 1. Reference here is exercise 1c of this book, so stay tuned. Our next concept is inverse proportion. So let's go through this concept. For inverse proportion, let's consider this a table number 2. I haven't written the number, but okay. So this table shows the time taken for a car and the time taken for a car to travel a distance of 120 km at different speeds. So x represents a speed and the time taken represents y in hours. What happens, we can see in each column there when the speed is increasing, the time is, see the speed is increasing and now the time is decreasing. So let's consider this case. What happens if the speed of the car increases? Okay, then that is very clear here, that if the speed of the car is increasing 10, now the speed is 20. Now then again in the column number 3 it's 30. We can see that its corresponding time is, with 30 it's 4, with 20 it's 6, with 10 it's 12. So as the speed is increasing, the time is decreasing. 10, 12, then 20 it's 6, then 30 it's 4. Okay, but is there any relationship with all these changing pattern? Let's see. If the speed of the car is, what if the speed of the car is double? Let's see. Number 10, the double of number 10 is 20. If we double the speed of the car, that means now it's 20. What happens to the time? Okay, so the time here is 6. All right, we can see that the double of the speed 20 and the corresponding time of 20 is 6, and 6 we all know is the half of 12. So if the time is doubled, if the speed is doubled, the time will be half, will reduce to half. Okay, now another case, if the speed of the car is tripled, 10 multiplied by 3 is 30. All right, 10 multiplied by 3 is 30 and this 30 and its corresponding time is 4. So if the speed is tripled, what happens to its corresponding time? All right, so we can see that the speed, the relationship is like, if the speed is tripled, 12 divided by 3 is what? 4. So we can say if the speed is tripled, the time will be 1/3. So we can see from this investigation that as the speed of the car is increasing, the time is decreasing proportionally. There is some pattern going on over here. All right, now next let's reduce the value of the car and consider their pattern. So what happens if the speed of the car is reduced to half? Let's reduce 40 to half. The half of 40 is 20. If the if the speed of the car is reduced to half, it's what happens to its corresponding time. We can see that initially it was 3. Now if we have reduced its speed to half, we can say that 3 multiplied by 2 is 6. So if the speed is reduced to half, we can see that the time is increasing and the time is doubled. What happens if the speed is reduced to 1/3? So let's consider this case. 60 divided by 3 is 20. If the speed is reduced to 1/3, what happens to its corresponding time? Yeah, you can see that 3 multiplied by 2 is 6, and this is our time. So if the speed is reduced to 1/3, its corresponding time will be tripled. Now we can clearly say that if the speed of the car x km/h increases and the time taken y hours decreases proportionally, and the speed of the car decreases and the time taken by the car increases proportionally, then such kind of relationship is called inverse proportion. We say that the speed of the car x is inversely proportional to time taken, and we also represent um, this relationship like this. Okay, x is inversely proportional. Now, as we have seen that this table represents inverse proportional relationship in which the one value increases, one variable increases and the other variable decreases. But in all the columns, in all the cases, the product of x and y, or the product of speed and the time, is same. See, 120, 120, 120. So if the product in all the column is same and we call the speed, suppose in this C1, if we call this speed is x1 and the time, its corresponding time is y1, x2 and y2, then we can write that the product will always be same. So okay, so what product is same? The product of 10 multiplied by 12 is 120 and 20 multiplied by 6 is 120. So we can write this like this: x1 into y1 is equals to x2 into y2. Okay, so this is our, we can conclude this as if y is inversely proportional to x, then we can write this relationship as x1 into y1 and x2 into y2. Now this is very important to solve further question, keeping this in mind that if three variables are known and one variable is unknown, we can clearly use this formula. Now to understand inverse proportion with the help of example, let's go through this question. Question number 1, exercise 1c. Before explaining anything, let's review the previous concept of direct proportion. What is direct proportion? Direct proportion is when if the one value is increasing, if the value of one variable is increasing, the value of another variable, its corresponding variable, will increase. This is direct proportion. Now, if the value of one variable is increasing and the other variable's value is decreasing, then this kind of relationship is called inverse proportion. Okay, now question number 1, part A. The number of the pencil Farhan buys and the total cost of the pencil. See, there are two variables, total cost of the pencil and number of the pencil. Suppose if Farhan bought 4 pencils and each pencil cost 2 rupees. So his number of the pencil would be 4 and the total cost of these 4 pencils is 4 multiplied by 2, 8. Alright, we can see 4 and 8. Now if Farhan wants to buy one more pencil, so now the number of the pencil is 5 and the total cost of the pencil would be, what would be? It would be 1, 2, 3, 4. No, it would be 5 multiplied by 2, 10. So we can clearly see here, if the number of the pencil is increasing, the total cost is also increasing. Is this the case of inverse proportion? No, this is not the case of inverse proportion. This is the case of direct proportion. Let's consider example, question number 2. The number of the taps filling a tank and the time taken to fill the tank. Okay, so we have a tank and there is one tap which is filling it. And suppose the tap will take 30 minutes to fill it, right? The tap will take 30 minutes to complete its job. If we are going to add another tap, what would happen to the time? Yeah, it's a problem. It's nothing but just the time will reduce to half, right? One tank will fill the tank, both of the tank will fill both of the taps will fill the tank in 15 minutes, right? So time will reduce. If more taps work on the tank, the time will reduce. So what kind of relationship is this? If the number of taps is increasing, the time will reduce. So this is the case of inverse proportion. Now, the number of the man laying a road and the time taken to finish laying the road. So again, two variables here. the number of the man laying the road. Suppose if one man has a job to lay a road, how long will he take? I think he will take ages to lay the road. And if 7 or 10 people will come to help him out to lay the road, how long will 10 people take? Of course, if more people would involve in this job, then this work will finish in no time, right? So the number of the man, if the number of the man increase, let's say from 1 to 10, if one man work, it will take, I think, 7 days. Let's suppose 7 days. And if 10 men will work, I think the time will reduce, right? 10 men will work maybe 2 days or 3-day job. So more people, less time. What relationship is this? This is the relationship of inverse proportion, right? When one variable, that is the number of man, is increasing and the other variable, the time, is decreasing. Now the number of the cattle to be fed and the amount of the fodder. Of course, if the number of the cattle would increase, the amount of fodder will increase. So this is not the inverse proportion. Let's go to another case. The number of the cattle to be fed and the time taken to finish a certain amount of fodder. Suppose if we have 100 tons of food and one cattle has to eat it. How long will it take? I think it will take 1 year to finish it, right? So if we have 100 cattle, how long will it take to finish the food? Of course, it will take less time to finish the food. So the time and the number of the cattle. This is the inverse proportion relationship.
Thank you for watching. Subscribe for more updates.